All right, students, welcome to the last lesson of our geometry unit. And for this session, we're going to be looking at 2D, which is on similar figures. Now, if you haven't already, please make sure you watch the previous chapters on, I believe it was 2B and 2A, wherein we covered a review on geometry, but then also a short units as well on congruency and proving that. So that was the previous chapter. And this is now the final one. And as a learning intention, our aim is to be able to understand figures and whether they're similar or not, and also looking at corresponding angles and understanding how all of that comes into play when it comes to similar figures. The other thing as well that's important is knowing your scale factor. Or you can call it the ratio, but that tells us how big or small a certain shape is by, and also using our scale factor to find unknown lengths, and hopefully we can all do that by the end of today. Alright, so last lesson we talked about a congruent shape. When we talk about congruence, I'll scroll up there real quick. Remember, we're talking about shapes, and in this case triangles that are exactly the same. Yeah, so that's what a congruent shape is, exactly the same. But if we're talking about similar figures, okay, that means that shapes are not exactly the same, but they share some similar parts to them. Congruent shapes, remember, have exactly the same angles and the same side lengths. But a similar figure will only have the same angles, but not the same lengths of the sides. Okay, so as you can see here, when it comes to similar figures, it's the same shape, but it's a different size. Okay, obviously because they have to be similar, so they have to be the same shape, but they are different size, so they can only be similar. So, but the only things that are the same are the angles. They have to be exactly the same angles. Corresponding sides are proportionate. So when we talk about a proportionate corresponding side, let's say you've got two triangles. That's the small triangle, and there's the big triangle. Corresponding sides mean, let's say if that's, I'm going to label this triangle A, B, C. We'll call this D, E, F. Okay. What this is saying that corresponding sides are proportional is, for example, here side AC, okay, is similar to DF. Okay, that's the proportional side or the proportion. We don't know what it is actually proportional wise, but they are the corresponding sides for those triangles. Side AB, okay, is proportionate to side DE, for example, or side BC has the corresponding side of EF, and they're proportionate. The other thing we're looking at when it comes to similar figures are scale factors. Okay, so the scale factor tells us how much a shape is bigger by or smaller by, or how big a size is, has been enlarged or has it been scaled down. So if you look at back to our triangles, there's a scale factor that tells us that this triangle has been enlarged into this size, and we need to know by how much. Is it double the size, triple the size, or is it half the size or a quarter of its original size? Okay, that's what a scale factor tells us, how much it's been enlarged or minimized by. Now, you'll remember in congruency, we had statements as well to prove that something is congruent. For example, if I drew, let's just stick to our triangles, and another triangle like that. Let's say for simplicity's sake that they are congruent, so A, B, C, D, E, and F. Remember the statement we used to prove that they're congruent. Let's say, let's just say again, I'm not gonna go through the whole process, but the statement looks something like this: triangle A, B, C. Let's just do it in green so we're not confused. Triangle A, B, C is congruent. So remember the equal sign with the symbol to triangle D, D, E, F. That's our congruency statement. Now, when it comes to similar figures, there is also, I'll actually label this their congruency statement. Okay, so when it comes to similar figures, we also have similar statement figures, or similar Let's just call it similarity statements, as it says there. Okay, we can either use either of these, but I like to just use this one. So you can see it's similar to the congruence, but it just doesn't have the equal sign, but it does have the squiggle. Okay, so in our congruent statement, we had that squiggle on top with the equals. Here we just got the squiggle on top, no equals. That means they're similar, not congruent. All right, let's look at some examples. So here we've got figures here, two similar figures. They're similar because they're not exactly the same, but they do share. Remember, when it comes to similar figures, same angles. Yeah, so these are all 90-degree angles. Great. But the side lengths are not the same. There are corresponding sides. So we know that AB, for example, corresponds to EF, or DA corresponds to HE, for example, or CB corresponds to GF. Okay, question A, would you say that the two squares are similar? Okay, let's answer that. Are they similar? Right, I'll write yes, because, okay, and we've got to have a reason, yeah, because they share, or you can say they have the same angles, exactly the same angles, but the corresponding sides are different. Okay, that's how we would answer that question. We'll go into more detail, different lengths. Okay, question B, what is the scale factor that the smaller square is enlarged to the size of the larger square? All right, so part B is now where we have to use the scale factor formula. Now, it's actually not too bad. You can use this as a guideline for your scale factor, but what I like to do is, in this question it says, what's the scale factor of the smaller square enlarged to the size of the larger square? So what that tells me is the smaller square was the original, okay, the original shape, and this is the new shape because it's been enlarged, okay, because it's asking what's the scale factor of the smaller square when it is enlarged to the larger square. So this was your old shape, it's been enlarged into the new shape. So by how much? Okay, now the scale factor rule says that it's the image length divided by original length. What I like to do is I write it like this, and it's the same as what the actual formula is, but I like to write it as scale factor is equal to new divided by the original. But when I say new divided by original, you got to look at the corresponding sides of the new shape and the original shape. So if we're going to use the new shape on the top, okay, and original shape on the bottom, for our formula, make sure you use the correct corresponding sides. In this case, I might use EF divided by AB, their corresponding sides, right? So in my formula, I would write EF divided by AB. Okay, they are the corresponding sides for this shape. All right, so when I do this, make sure you look at the side lengths, yeah? So according to this, EF is going to be 3 and AB is 1. Therefore, the scale factor, I can just write it shorthand here, the SF or scale factor, let's actually go and write the whole thing. The scale factor is 3 divided by 1, which is 3. So what that means is this original shape has been multiplied by 3 to get the new shape. All right. Question C. Okay, if the largest square, let's do that one. If the largest square, okay, is enlarged by a factor of 5, what would the side length of the image be? Okay, so let's go do C now. Let's say the largest square now has been has a scale factor of 5. So now instead of having a scale factor of 3, which means that to get from here to here, you have to multiply by 3 because it's 3 times as large. For question C, we're going to see what happens if it's multiplied by a factor of 5. Okay, so that means what's the new side length of the image? Oh, well, if the original length, let's just go with one of them, AB is 1, okay, and it's being enlarged by a scale factor of 5. So if we just go 1 times 5, the new side length would be 5 centimeters. Because it's a square, it's all the same on each side. So that question is just saying if you enlarge it by 5, so if you enlarge this new shape by 5, what's the new side length going to be? Well, 1 times 5 is just going to be 5. So it's 5 centimeters. All right, let's do some more examples. I might only do a couple here, and then we'll do that one and then that one there. All right, so let's find the scale factor for these images. What I like to do here, guys, is always make sure you label the sides of the shape, yeah? That just makes it easier to actually do the questions. So you can, in year 11, I always talk about year 11 and year 12. This is how they want you to do it, all right? So for the first triangle, let's just call this triangle A, B, C. And I'm going to be fancy here. Let's call this one X, Y, Z, just because I can. Okay, so let's find the scale factor for this. All right, so use the scale factor formula, scale factor. And now for finding the scale factor in these sorts of questions, I'm just going to always assume that the second shape is always the new shape. So if this is the original shape and this is the new shape, okay, let's treat it as that. So it's new divided by the original. And remember, for these questions, to find the scale factor, you have to use the corresponding sides for the scale factor. All right, so on my new shape, I'm going to use YZ. Yeah, so I'm going to go YZ, oops, divided by, and on my original shape, the corresponding side for YZ would be BC, which is there. So BC. And then you just change the length there. So YZ is equal to 8 and BC is equal to 4. Therefore, the scale factor, there's a lot of colors here. The scale factor is 2 because 8 divided by 4 is 2. Right, not too hard. Let's try shapes. Ooh, D. D looks a bit tricky. It's a 4-sided shape. We work with 4-sided shapes, but this time we'll. I'm going to call this A, B, okay, C, D. Okay, now the naming of these shapes is very, very important, especially in the order that you do it. Okay, when you actually do these, the reason being is because the corresponding sides have to be the same. So on this shape, okay, let's be mindful how we draw. I'm going to use WXYZ, okay? So look at where A is. It's on that tip there. The corresponding angle or side for this one, this shape here would be there. So if I've called this side A, I'm going to call this as my starting letter. I'm going to get W. Okay, it has to be the same. Okay, B is where that angle is with the circle. You see that? So that means I'm going to call this side X as my second one. C, which is our third one, is the angle with the square. So I'll call this one Y, which is our third one on the big shape. And then Z is, D is the fourth one, which is there, and that's the remaining one here. So I'll call this one Z. Notice how it's always the corresponding angles that you got to name. You always got to have corresponding labels for both of the shapes here, always. So let's find the scale factor. Remember the formula? Actually, I'll just call this my original. This is my new. Okay, always treat it like that unless the question might ask otherwise. Okay, just double check it. So in this case, the scale factor is going to be the new divided by the original. Okay. In this case, find the corresponding side. So I can see on this shape that I'm looking at, the corresponding side I want to use was probably going to be WZ and AD. Okay, so let's write that down. WZ divided by AD. Okay, so WZ here is 21. AD is 14. All right, so the scale factor there is going to be, if my math is right, it should be a fraction, which is 3/2. And then if you put that in decimals, it's 1.5. So that means this shape has been enlarged by 1.5 in this shape. That's been times by 1.5 to get to that shape. Cool. All right, let's go. I think that's fine for that one. Let's go and do this example, and then we'll do the last one. So in this question here, these two triangles are supposedly similar. Okay, so ABC is similar to DEF. Actually, no. It should be this. If I've called this ABC, sorry, this triangle should be EFD. Okay, so be mindful of how you name these when you're actually doing these shapes. In triangle ABC, which vertex corresponds or matches to vertex E? So for question A, in triangle ABC, which is this one, which vertex corresponds with vertex E? So which in vertex E here, for this triangle, where is it in ABC? That's what it's asking. So it should be vertex A. Okay, right there. So E and A, or angle E and angle A, are corresponding to each other. Question B. In triangle ABC, which angle corresponds to angle D? Okay, so in this triangle, and you have angle D here, where is angle D? Or what's the corresponding angle for this triangle for angle D? Well, I can see angle D has no symbol there, so it should be angle C. So angle C. Okay, in triangle DEF, I don't quite agree with the labeling of this. It should be EFD, but that's okay. Which side corresponds to BC? All right, so if you have in this triangle BC, which is this, which side is the corresponding here in that triangle? Well, that's BC. So you look at BC, you've got that angle, and it goes up to the angle where there's nothing there. That would mean that it should be FD on the new or the other triangle. So we would write here FD. All right, what are we up to? D. Give the statement for the two triangles with matching vertices in the same order. So now this is where it matters and how we should write this. So the similarity statement, yeah. If the question's called this triangle ABC, let's call it that, yeah. So it's going to be triangle ABC is similar. So remember, with the similarity statement, there's no equal sign, it's just a squiggle. Now, if I've called this A, B, C, so A, B, then C, okay, I have to start here on E. Okay, so it's going to be a triangle E. The second one on ABC is B. So, and that's got that angle. So now I have to call this EF. D is the last one. Okay, that's it. Easy. All right, last example, and then that'll be the end of this video. So now this is sort of the main part of scale factors, yeah, and finding, because we need to be able to find unknown corresponding sides. Okay, so in order to do that, there's two things. You need to find the scale factor or the ratio, and then multiply that ratio with whatever side you're looking for on the corresponding. Okay, so how does that work? Say, for example, in this question, yeah, you're looking for X, okay, and in this shape, the original shape, you've got 3. How do you find X? Well, you need to find the common ratio first of one of the corresponding sides, and once you've done that, get your common ratio and multiply it by whatever it is to get the unknown side. So let's do that. Let's put it to practice. Let's write first one here. Let's write the similarity statement for the following two shapes. So I might call this shape, it is a trapezium. Oh, actually, no, trapezium. I'll call it trapezium CBAD. Okay, is similar to trapezium and I'll call this one. Remember, watch out for how you call it. So if I've called this C B A D, I have to call this one G F E H. Okay, so G F E H for that one. Part B, this one's a little bit tricky. Okay, I'm gonna write it here. So for part B, we need to complete the following. EH, divided by something is the same as FG divided by something. Okay. Now, what we're doing here is we're just actually finding the corresponding sides for both of these. So if we have EH on this part of this trapezium, where is its corresponding side on this trapezium? Well, it would be AD. So EH over AD is the same as, all right, well, FG on this trapezium. So where's its corresponding side on the other one? There, BC. Now what that's saying is, if you found the scale factor here with those corresponding shapes, it'll be the same as the scale factor here, or it should be. It would make sense. That's all that question is saying. So let's actually find the scale factor for part C. Find the scale factor. All right, so let's use the rule again, scale factor. Okay, you go new divided by the original. Now, what I'm going to do here, guys, is I'm going to find two scale factors. Okay, we're going to do this twice. So let's do it the way that we've been learning so far. So for now, let's treat this as the original, and this is the new. All right, so for this first one, my original there and my new's there. So for my new shape, I'm going to use the corresponding side of GH, which is there, which is 4. So let's just write GH. Oops. And my corresponding shape there, is going to be CD. So, oh, so sorry, not liking me. All right, CD. Okay, so doing that, GH is 4, CD is 2. That means the scale factor is going to be 2. Now, that's if we treated this shape as the original and this shape as the new. Okay, so I'm going to go ahead because I did mention before that I'll find a scale factor again, but let's do D first and then we'll find a scale factor again. So in question D, it asks us to find the length of X, which is there. So remember, this is my original, this is my new. So what we're going to do is we're going to use a scale factor to do this. Now, in order to actually do this, it's pretty straightforward, yeah? So what this is saying is, what the scale factor tells us, okay, is we have a scale factor of 2. So if we go back to the shape here, that means to go from 2 to 4, we have a scale factor of 2 because it's times by 2. So that means if you want to find this X to go from 3 to this unknown X, we are multiplying by 2 because that's the scale factor. So that means to solve this, X is going to be equal to 3 times 2 because it's that corresponding side times the scale factor of 2. Therefore, X is 6 centimeters. Okay. Oh, sorry, meters, my bad. Okay. Cool, that's cool. So now what we need to do is for question E, we need to find Y. So what we're going to actually do now is we need to find a scale factor again. So if this is my new shape, and that's my original shape, if this was my original shape and this is my new shape. So we're going to swap it around now, because what I like to say to my kids is the shape that has the unknown is going to be your new shape. In this case, this is the one with the unknown now. So this becomes the new shape, and this will now be our original. So let's find a scale factor for that, for E. Because I mentioned we're going to have to find it twice. Scale factor. Okay, so it's going to be new divided by the original. If you want to, you don't have to necessarily do this step, but I am doing it so you can just see everything step by step. Okay, so the scale factor, new divided by original. In this case, I can actually use CD again for this. So I'm going to go CD. So this is my new shape, yeah? CD. And the corresponding side on the original one is GH. Okay. Now, let's solve that. So that means the scale factor here is going to be 2 divided by 4, which equals a half, or 0.5. So that means if this is our original shape, and we want to go and find the unknown side there, we are multiplying by a scale factor of 0.5. So relating that then to the question, we have to find out what y is. What is y? So if on my original shape we have a value of 8, to find out y, remember you're going to multiply it by a scale factor of 0.5, because it's going to be smaller. So times by 0.5. So in this case, y is going to be equal to 8 times 0.5, which equals 4 centimeters or meters. Okay, because it's a scale factor of 0.5, or it's being minimized by 0.5. Now I know that maybe that might be a little bit confusing, so what I'd encourage you to do is actually watch this video again, or I might upload some more videos. We'll see how we go. But if that's all made sense to you, young'uns, please go ahead and do chapter 2D in your textbooks. I'll upload questions as well in the post that I'm going to make in our Teams page. But thank you for listening.